Okay, so let's do this question. Prove that 1 minus nc1 and then 1 upon x upon 1 plus nx, nc2 1 plus 2x upon 1 plus nx squared and so on. This thing will turn out to be 0. So it's up to minus plus what? I think up to n terms. I don't know. So this thing turns out to be 0. Okay, that's fine. So how can we do that? Well, let's see. So this is like 1 plus r upon 1 plus nx to the power of r, and then you got ncr, right? Okay, wait a second. It's not exactly that thing. So when you put r equals to 1, you should get a negative, right? So like this thing into negative 1 power r. Okay, that's nice. uh so now what? Maybe we can actually take this out. So this is going to be equal to ncr and then negative 1 upon 1 plus nx, this thing to the power of r. Okay, and plus you got r ncr, which can be written as I think n into n minus 1 cr minus 1, and then you will have negative 1 upon 1 plus nx to the power of r. Okay, so now what? So got n minus 1 r minus 1, isn't it? Yeah, so we'll just take one of these out and then you will get an r minus 1 over there. So like that should make sense. Okay, so this is going to be equal to ncr, um wait, isn't that plus rx? Yeah, that's more like, it's like rx. So this thing is going to have that x term over there as well. Okay, cool. And this is like from r equals to, yeah, you put 0 over there and then you put n over there finally. Okay, that makes sense. So like this is ncr, and then negative 1 upon 1 plus nx to the power of r. And what about this thing though? I think we can write it like this, like we can write it as x into negative 1 upon 1 plus nx, and then n obviously, and n minus 1 cr minus 1, negative 1 upon 1 plus nx to the power of r minus 1. Well, that should make sense, right? That looks good. Okay, so now we want to sum this up. So like we want to sum this from r equals to 0 to n, I think. Yeah, so like summation from r equals to 0 to n of this complete thing equals to summation from r equals to 0 to n of that complete thing. Well, like, just break it in two summations. Yeah, that will be better. uh why is this there equals? Okay, supposed to plus over there. So like summation from r equals to 0 to n. Okay, so now what? Well, this thing is actually pretty doable. It's just 1 minus 1 upon 1 plus nx, that thing raised to the power of n. Yeah, so the first sum is pretty easy. What about the next one? So it's kind of complicated. Well, we can take that x out because it's almost a constant now. N is a constant, and in fact that negative 1 upon 1 plus nx thing is also a constant. So just take that thing out. So plus negative nx upon 1 plus nx. And now what? Well, we talk about this thing. Yeah, n minus 1 cr minus 1, isn't it? Okay, so once again there's a problem. But what happens when you put r equals to 0 in there? Yeah, you get a problem over there because if r equals to 0, in that case we cannot say that r and cr is going to be n into n minus 1 cr minus 1. That thing is only valid for r bigger than or equal to 1. And in fact when you put 0 over there, that thing actually becomes 0. So it's the same as counting that term. Sorry, it's the same as not counting that term. So we can just start from r equals to 1 and still the series will be the same. Okay, so in that case this thing can be written as, well, n minus 1 c0, and then this thing raised to the 0th power, and then plus n minus 1 c c1, this thing raised to the first power, and so on. So this is going to be like 1 minus r upon, wait, is this r or what? I think it's 1, not r. I don't know what that thing is. It's actually 1. So 1 upon 1 plus nx, and that thing raised to n minus 1 power. Well, yeah, that should make sense. So now what? Well, we can take this thing out. So like this thing raised to the n minus 1 power, that's common, and then the remaining stuff is 1 minus 1 upon 1 plus nx. Okay, and this thing minus nx upon 1 plus nx. Yeah, that's kind of weird. So hey, that makes sense. It's like, look at this and that. If you add them up, you just get negative of 1 plus nx upon 1 plus nx. Well, that's just negative 1. So 1 minus 1, that's 0. So like this complete thing actually becomes 0. So this actually should turn out to be 0. Yeah, that's nice. So we have proved that this series actually turns out to be 0. And yeah, that's nice. Okay, I will see you in the next one.